Assalamualaikum everyone, this is Juwairi Ahmed. I'm roll number 2022, CE10, computer engineering student at UET Lahore. So today we will see the next lecture 9, which is all about models, model perspectives, external, internal, structural, behavioral. Then we will see the use cases, which define tasks with external interactions. And we will see behavioral models. So firstly, we will see this link. Yeah. So this is basically this basically show how we can define the use cases. Here we have three actors: procurement, librarian, and then brower. Then we will have then here we have different tasks. These three actors can do, and this is basically the main example of. शुक्रिया आंटी अब सब कुछ नहीं होगा. So now, okay. So now here, okay. Now here we will see that this is basically the example of use cases diagram and how we can make it. So now we will see the lecture in details. This is basically lecture number 9 of CS5150. Here we have static analysis. What is static analysis? We actually review the code without executing the application. We can check for syntactic errors, likely bugs, and violation of style guides. The tools for them include compilers, linters, formatters, find bugs, and code sonar. Now models. Purpose of model simplification of reality facilitates communication during steps like these three, which we have discussed: requirements, architecture, program design. Then larger, more complex projects benefit from more from formality. Then we have actually representing models. How can we present models? We have UML. UML basically includes all type of diagrams that we create using our software engineering process, which include use cases. Then we have information architecture. Then we have sequence diagram, etc. Now we have can serve many purposes, facilitate discussion, etc. So the diagrams make it easy to for others to understand them as well. Inode code can have multiple models with simplification serving different perspectives, etc. So sometimes pseudocode is the clearest specification. So we use diagrams or pseudocode more. Now model perspectives, external represent the simplified context of the system, and this is basically shown to the client or to the users. Interaction, how do user and component interactions proceed. Structural, how are the system components organized and how is data represented to the user. Then behavioral, how system responds to the events changes over time. We will also see this in next lectures. Interaction models, they basically include use case diagrams and sequence diagrams. Use cases, I think I have already show you this use case diagram. Yes, use cases I have already shown you. What are so they basically include actor and a use case. These are basically the use cases, and this is basically the actor. Then textual description basically includes metadata, which is data about data. These are the basically things that it includes. Then after that, this is basically an example which shows this diagram. You can actually understand it as well. Alternative alternative path to successful completion of use case. Take here example. You can see the example as well. Then we have relationships which include extents, which differ extra detail to other use cases. And then we have useful for alternate flows and exceptions. Includes means that it includes steps from another use case, and then useful when common procedure is required in multiple contexts. This is basically what I was talking. So then we have sequence diagram. We will see the sequence diagrams more in detail in the 16th lecture, and I will also make a separate video as well for it. So basically, sequence diagrams show the sequence of interactions, like after which step we will do which step, etc. We have behavioral models, which include model dynamic behavior of system during execution. How does system process data or even respond to the events, different events which occur, like when we click a button, then what should be the data, what should be done, etc. Then we have data-driven models which show sequence of processing steps from input and output. And then we have event-driven models which include how the system respond to events. Let me see. Okay, yes, it is going. Then we have data flow activity diagrams. Activity, they basically include different type of things with different symbols. For activity, we have rounded rectangle. For data, we have rectangle or labeled edge. For data source sync, we have rectangle, and for beginning and end, we have circle. For university admissions, you can see the data flow like this. You have applicant, then we have application form, then we have assemble application form is submitted. So then after that, completed application, the application is completed, and then we evaluate it, and then we will actually, yes, we will either accept the student or either reject him. But in actual, when we refine it, then we get this long uh, actual example. So basically, there are also, it shows that there are also many other factors, but this is basically the kind of DFT diagram, which is level 0. What is DFT diagram? DFT diagram basically shows the different data flow of a complete structure, complete app, or etc. And in level 1 DFT, we have very simple implementation, and after that we see more factors as well. How to specify logic? Data flow and sequence diagrams show high flow must be augmented by specifications for low level behavior. Then we have decision table. Basically, this shows decision table. That is actually sequence diagrams we have already discussed, and data flow is also discussed. Then we have decision table as well, where we actually see the thing that whether we should accept it or not, accept him or not. Then we have flowcharts and pseudocode. Flowchart is basically in this format, and then pseudocode is basically the main logic of the code. It shows logic and used to specify computer programs before modern programming languages. Pseudocode basically includes compact and precise, composable. Yes, it is working. Easy to implement and harder to see flow. So yes, you can easily write pseudocode, but it is hard to write the codes. And also, in case of diagrams, diagrams show the main logic very easily as compared to the pseudocode. Then mathematics, we here also see differential equations, integrals, filters, etc. Interpolation basically means that uh, if we have the idea of two points, then we also know we can also make some guess about the data which is given in between them. Then we have document progression and approximation and domain transformations, etc. Frequency versus time domain, continuous versus discrete. These are basically the main things. Then we have state chart and transition diagrams. For transition diagrams, I think you will all remember the state diagrams you have learned in DLD, digital logic design, which basically shows that after which step we will go to which step, and actually the change in the states. Transition tables. Transition tables basically specify transitions in textual form. Basically, these are basically the tables like with column and rows, etc. And they show the transitions in the textual format. Useful when transitions are dense, like more conditions are applicable in most states. For example, physical buttons on embedded device. So if we have to see which button will do what, so we will use the transition tables. Can usually check for completeness. We can easily check that whether the logic is completed or not. So this is all for ninth lecture. I hope you all liked it. And it is if you have any question, you can actually ask in the comment section. Thank you so much.